Hello friends, Jov here. Welcome to the test-driven development screencast. This video is continuation of the search functionality where we are following the classicist approach of the test-driven development. And the aim of this video is to plug what we have built so far using the search functionality into an Android context. So basically we are gonna plug the thing into an Android application and see it running. So let's open the code here. Where we ended up in the last episode is we have an implementation of the remote search service that actually agrees on the contract that we have for the search service. And now we have to assemble the whole thing and plug it into an Android and see how that's gonna work. So off the camera, I have prepared here an activity for those that are not familiar with what is the activity. The activity is an entry point, a screen in Android. So when you open the app, whatever you see on the screen, basically that's an entry point. The screen has an activity, and then this activity is the entry point into the application. So here what I have is I'm basically inflating a layout to render, and then that layout contains a search view and then another view, but basically that's a widget where we are typing the actually let's maybe run this and see how it looks on Emulator. It's gonna be easier for me to describe. So here is the Emulator, and basically this layout, the search view is this thing here where I can type, and then if I submit now the query, nothing really actually is plugged there, so it doesn't really work. So what I have here is in the setup of the search view, I'm applying basically a text query text listener where I can take the query, and this is the to do here where I have to actually ask the searcher that we built so far, ask the searcher to perform the query. And I also have to set up basically observe the search states from that observer so I can render them here. So maybe, but the first thing that we have to do is, let's maybe switch back to the tests. So I want to run all the tests because we are gonna be making a call to remote, and I have the backend already running. Here I can show that one too as well first. So on my localhost 8080 port, I have a my backend sort of running, and then I can perform searches here. And then if I type something like, I don't know, key, there is no such thing there, or like, let's say I have cable, and if I put there sort of short query, the backend will return back like 406 as we had in the contract that I described in the previous video. So I have my backend running here, that's good, and my test should be also running. Yeah, so because we are gonna be making call to a backend, how we described, I actually spoke about that in a previous episode. How we described the call is we are using retrofit, and then this is the actual function. Then retrofit would create an implementation for us out from this interface. But actually I have to make this function a suspend one because the call to the backend is something that may take time. So it's not, it's not running in memory, so it might need some time. So I'm better if I just make this suspend. So it's pity that we didn't design the entire thing with a suspend, but it's fine adding it right now, as we are gonna see. So now if I run the test, I'm gonna have compilation issues. So basically if I go now ahead and fix the compilation issues, I mean, I can start from there basically. So first, let's see, make find matches suspend. Yes, I can do that, but basically that's not because the find matches is coming. Actually, I'm overriding from the search service. I would be better off if I just do it suspend here. Now if I run again, it should point me back to I have to just follow the compiler to tell me what are the things that I'm missing here. So here I have the repository, and if I make this one suspend, and then also this one suspend, so I'm just working backwards from the actual API that is really deep down in my hierarchy, up the call stack towards my searcher, and then eventually, and here I'm here in the searcher, and then this is where I'm making the call. So basically here I want to offload from the main thread and use, for example, it's gonna force me to actually do something about it. Let's instead, for now, just hardcode here. I'm just gonna use a view model. So that's basically a type that comes from the from the Android Jetpack components, and it has predefined way of having a scope. I'm gonna skip talking about that too much because that's sort of I have to explain how the structured concurrency works, how the coroutines are working on Android. I would like to skip that if you're not familiar, but basically the idea is to be able to offload, like switch threads in a way. And then here what I'm gonna do, I'll do a view model scope and then launch. So now this is gonna be spawning up a coroutine, and then I'll be able to launch to call the perform search, which is a suspending function. So I'm more in favor of having this into a dedicated method or a function. And now if I run the tests, let's see where I am. Okay, I have to add suspend modifier also for the fakes, because those were the fakes that I have. And yeah, and here I have a test. I think that's gonna be the last error. Now my tests in the contract, I guess, yes. Because they are making a call to a suspending function, I have to make them run blocking, actually. So let's do that in one run. I don't really like that. I have to, I couldn't make sort of more baby steps and like fix the things in sort of, less steps, but it is what it is. At least I have a way to roll back if I screw up something at once because of the source control. Cool, now my tests are back to green. And how about maybe just commit this so far? And I'm gonna say not introduced, but maybe made the search API suspending use a suspend function okay. And now actually we can go to our search activity and construct the whole thing. Like basically we have to construct the searcher. Typically we would use a some sort of dependency injection container for this, or some maybe even manual dependency injection. So we wouldn't maybe construct everything here, but just for the sake of this example, I'm gonna do it right here so we can see how everything is gonna work. So basically we need first a searcher, and that's gonna be a searcher. It takes validator and a repository. And now the validator, oops, is gonna be a query validator, and it's gonna take, let's say, 2. Then, oops, I would be better off if I do this. Repository is gonna be a repository, and it takes a search service. Now the search service is gonna be a remote search service because we want to hit the real API. And this one's gonna be what's the problem here? Oh, I have to initialize it. And here we need a search API. Let's create a property. So the search API, the way to construct a search API is gonna be, as I said, we are gonna use retrofit. Create search API class Java. So that's, now let's create the retrofit instance here. And that's gonna be retrofit builder, and then I think I have to import this one. Yeah. Base URL, we need HTTP. I think because this is emulator and the emulator needs to hit to my local host of the computer, not if I put here, for example, 127.0.0, it refers to the local host of the emulator. So I want to refer to the local host of the PC where the emulator works. So the way to do that is to do 10.0.2.2, and then I need the 8080 port, and that's my base URL. And then I need to add converter factory, which is gonna be a Moshi converter factory, create, and then build. So that's gonna be my retrofit instance. So basically I have everything now. I have the searcher constructed. And what I have to do here is call the searcher. Well, first I have to check if the query is not null. And if it's not null, I can ask the searcher to do the search, passing the query. And of course I have to now also observe the state. So basically what I can do is searcher search state live data observe. So I'm gonna pass this as a lifecycle owner, and here I have to say I'm gonna do some sort of pattern matching. When it is search state search state matches, let's say display matches, and then I'm gonna pass the matches there. Can I scroll down a bit? Is search state no match found, no match for display, no matches for query. Then if it is a search state I don't know, offline, now let's handle the errors. Display offline, offline error. Is search state bad search, let's say display bad search error, and then the search state bad query, display bad query error. Let's create these functions here, and now I have only as I said, I created basically a text view where I'm gonna be displaying the current results. I'm gonna use that one, so it's called result view. Text is error performing search, let's say, and then yeah, I'm gonna create them one by one. So result view text, I'm gonna copy this. It's gonna be bad search. Oops, sorry. Here it should be invalid query, let's say. I mean, of course, even it shows me a warning that I shouldn't be hard coding strings here, but instead I should use resources, you know, so that we can localize the application later. But that's not gonna happen in this video. I think it's too irrelevant for now. So yeah, here would be error performing the search. Then this one's gonna be you seem to be offline, let's say. Then this one would be no matches found for query. And lastly, we can display the matches. Okay, I think now that the activity looks okay, and now if I run, let's see what happens. I'm gonna run the app, and so if I, for example, type dev and search, so it's gonna show me all the results that are matching the dev, where this DEV is included. If I search for cab, let's say, it should tell me cable, Fabcam. What if I do CA? It should tell me invalid query because we configured in the code the query validator to take at least 3 characters. So if I, for example, switch to, let's say, offline, I turn off all the connections, it tells me that I am offline. So yeah, I think that's gonna be the app. And if I go back to my tests and run them, they are all green, which means I'm good. And then maybe I can just commit this. The app makes real calls to a real backend. I think that's gonna wrap up our exercise for the search functionality, doing the inside out approach. One thing that I want to point out is that in the searcher now, in the searcher here, I am launching, when I launch this coroutine here, I'm still working in a main thread. So for those that notice this one, for the Android developers watching this, What I should have done here is switch, like do this repository perform search. I should have wrapped it into a with context and then put here a dispatcher that's gonna be sort of doing the job in the background. For example, I could have introduced here, I think it's sort of irrelevant for this episode, but basically one way to do that is to, for example, have an interface where I'm gonna define what's gonna be the backend, the background dispatcher. So in production it's gonna be IO, let's say. For the test it's gonna be, let's say, the main, because like that's where the tests are gonna be running. And I think I can plug different based on the what I'm executing. That's one way to do that. It should be easy. And additionally, I want to point out, if this was a real application or a real code, I mean a real sort of production app, I would have also written an acceptance tests for this feature. However, I'm gonna skip doing that for the inside out, because I've done the same for the outside in. So if you're interested, if you want to see how that's gonna be looking, how that's gonna look like, you can click on the top right corner, and the link will directly bring you to the acceptance test for in the other series, and you can see, because it's gonna be basically the same thing. I don't want to repeat myself. So I think those are the things that I wanted to cover in this particular video. But I'm thinking to actually create a dedicated episode where I'm gonna talk more about comparing these two approaches. So the first series was about doing the outside in. So we started from the very outside of the actual system and built inwards. This approach in this series, what we started off with the actual core, with the very algorithm, and then we started building on top. I would like to talk about what were the differences, what were the things that went differently, and yeah, what were the similarities, what are the advantages, the disadvantages, that kind of things. I think it's gonna be interesting, and yeah, I think it would take a full episode to talk about that. It might be slightly shorter, but yeah, it doesn't. Yeah, we'll see how that goes. I think it's gonna be enough for this one. So I'm gonna thank you for the attention and for the time watching this. I hope you find it cool and you like it. So yeah, I'm gonna catch you in the next episode, and then in the next episode I'm also gonna announce what we are gonna be doing, how I'm gonna proceed with this. So stay tuned, it's gonna be very interesting. Cheers!